Now, let's take a look at the second question. So, if we view from the front, it is having 3, 4, 1, and 2 as the tallest columns. So, we can mark 3, 4, 1, 2 there on the top view. And if we are viewing from the left, we have 1, 3, and 4 being the tallest columns. So we can mark 1, 3, and 4 there. All right. So first of all, we can try to mark all the ones, because in the rows and columns of ones, there can't be anything taller than 1, right? So that's what we have. And then we can also see that in this column, there's only one box, which is going to be a 4. All right, because the 4 is right there. So now we have 4 boxes left. And we want to know how many different solids can satisfy the 3 views. So first of all, if we look at the last column, there are 2 boxes, let's say A and B. The maximum of A and B are going to be 2, right? Because of the column number 2. So it means that if you look at this row of 3, that will be definitely a 3 there. Because A and B both has to be equal to or smaller than 2. So it means that in the row of 3, A cannot be 3. So there has to be a 3, which is the one that I have just put down. And now you can see that for A and B, they can actually take different arrangements. So I just need at least one of them to be 2, which means that A and B can take the corresponding values to be. When A is 1, B has to be 2. When A is 2, B can be 1, or when A is 2, B can also be 2. So these are the 3 different ways that A and B can be. Now if we look at the bottom left corner, like this box, so I'm just going to use another color. If you look at this box, say we are calling it C, all right? So this box can take different values between 1 and 3, because it doesn't really affect the front view or the left view, because like the maximum number 3 and 4 has already shown up in the corresponding row and column. So you just need to make sure that it's not greater than 3, which is the column number, and not smaller than 1, because like it can't be having nothing there since I have a top view. So C can be 1 or 2 or 3, which is also 3 ways. All right, so it means that I have 3 different options for C and 3 different sets of options for A and B together. And now, under these circumstances, we can see that C, like what I choose for C, doesn't really affect what I choose for A and B, right? So it means that I am doing a choice that is under a first next scenario. I just need to choose one of them first and then the other pair next. So we use multiplication to help us count the number of ways. So the total number of ways is going to be 3 times 3 equals 9 ways altogether. And that's going to be the answer to this question. All right, so the answer is going to be 9 different solids.